Hello and welcome to this session. In this video, we'll outline the approach to connecting the AutoScholar advisor system with an academic institution's data while still being secure and compliant with the protection of personal information. We'll look at the types of data moving through the system, both from the institution and the AutoScholar, and understand better how the AutoScholar service works. We also show how the process of creating the connection can be eased and simplified and set up in a relatively short period of time. Let's talk about the flow of data, POPI and security. This image shows a simplified view of the data flow. The user is operating a device in which an interface is rendered. Through the interface, the user can access analysis methods and models from the AutoScholar, as well as institutional data that user is allowed access to. We will expand on this simplified picture later. For now, notice that the flow of institutional data is only ever between the user and the user device. At no stage is institutional data shared with an AutoScholar server or staff member. So how is the system able to deliver its functionality? It works because the processing of the data only happens on the user's device. When the user asks the AutoScholar, for example, which courses they need to put more effort into, the interface will ask the AutoScholar for the analysis methods to answer the question, and it will in parallel ask the institution for data about that student. The AutoScholar will send back to the device some analysis methods and some parameters for the model to run accurately. It doesn't need information from the institution to do this. In parallel, the institution server has received a request from the user device for some data. The institution server will check whether that user should have access to that data before sending it. At the user device, the data is applied to the analysis method, and the advice is worked out there in the background, and the results rendered to the screen. The point here is that the user has now been given the correct advice even though the user's data has not been shared with an AutoScholar server or staff member. This is the magic of so-called client-side computing. Since the data is never transmitted to the AutoScholar service itself, it is not even possible to break compliance with the POPI protocols. It should be noted that from our perspective on the AutoScholar side, we don't want your data. It would not only cost more for us to maintain your data on our server, but it would cost more for us to tie up our servers processing your data. A much better approach is for us to pass you the method for processing your data, and for your device to do the processing. Today we have most people walking around with at least 2 GHz of processing power in their pockets. You have what you need to process your own data. What is of interest to us from the AutoScholar side is the accuracy of the advice given, but it is to the discretion of the user and the institution whether even this anonymized feedback is shared back to the AutoScholar. We note further that the AutoScholar does a great deal more than just inject analysis methods to the user. It is not just an interface to your data. So what is on the AutoScholar servers? Let's show some examples of this. In the curriculum design component of the AutoScholar, the user breaks down courses or even whole academic programs into a collection of concepts. The user also sets the relationships among these concepts so that we can create a map of the concepts across the course, or even the whole academic program. Institutions in general do not store data like this in their database. So to grant this service to its users, the AutoScholar stores this data on its own databases. Since this type of data bears no privacy issues, it can be shared across the various institutions subscribed to the AutoScholar. All users therefore benefit by contributing concept data, and the AutoScholar plays the role of a centralized and shared tree of knowledge. Another perhaps clearer example of this is in the automated assessment generator. The AutoScholar practice and assessment component helps a user define a question along with variants that can be used to randomize the question and even create solutions that can be checked against a student's submissions. A user can define such questions, but to record them, again, because institutions don't store this type of data, the AutoScholar provides databases to its users for this purpose. When the users contribute questions to the AutoScholar database, we have a growing repository of questions that all subscribing institutions gain access to. This increases the number of problems for students to practice, and eases the process of developing assessments by instructors. These are just 2 examples of shared data resources in the AutoScholar. In addition, on the AutoScholar servers, there is a large quantity of data which is needed for the predictive models that have been trained over a decade of operation. These models live in their own data warehouses and are supported by their own sets of libraries. When called upon, They send copies of the models to a user's interface for constructing its advising. These include generalized machine models that aid in prediction of student and course outcomes, and the identification of at-risk behavior. Research in this field spans more than a decade, and is a never-ending process of continually training models to improve prediction accuracy. On the research side, the AutoScholar also makes available remote or cloud-based computing resources and access to microservices such as cloud-based computing, map location GIS services and many more. If this all sounds complicated, please note that all these services are integrated at the back end. From the user's perspective, the system is simply showing advice relevant to that user's position in one seamless interface. The main point is that institutional data remains in a closed circuit between the user and the institution, and is never shared with any person or machine outside of that loop. The more detailed descriptions of the data flow are documented in the AutoScholar technical specifications. Security is a different matter to protecting privacy and personal information. In the case of security, we are concerned about the possibility of a hacker gaining illegal access to data. First, it is clear from the previous section that security of institutional and user data is only dependent on the institution. Since the AutoScholar never receives institution data, a hack attack will not have any effect even if it is successful. It is really the security level of the institution itself that determines whether institution data is vulnerable. If hackers do attempt an attack on the AutoScholar side, they will encounter SHA-256 hashing and encryption. Salted public-private key approaches are used. All transfers are through a secure sockets layer, and all database queries are through prepared statements. There are no known methods of breaking this level of security. All hosting is through Amazon Web Services, which implements continuous logging and backup services. Now, even though the POPI rules are respected, and even though the institution data only exists in its own circuit, this data has to be in the right format. Otherwise, the AutoScholar model copied to the user device won't know how to read that data. We accomplish this by publishing what's known as an Application Programming Interface spec from the AutoScholar side. Institution database admin staff read this API spec and install an API to answer the calls for data that their institution's members will be making. The API is specific to an institution, because one institution may store its data in a completely different structure to another institution. For example, when storing student course results, each institution may use different table names, different column names and other naming conventions. There may even be institutions who don't use tables and columns at all, but rather graph databases. None of this matters. The published AutoScholar API spec defines the calls for data that the user device will make, and it defines in what structure the data should be sent in response. It doesn't matter how the institution stores its data, only that it be reshaped to comply with the specified AutoScholar data structure. This mapping is built as what's known as an Application Programming Interface, or API. This standardization is already showing unexpected benefits. One of our participating institutions is using the API internally to drive research into teaching and learning. It also aids in creating standardized reporting to national education and accreditation bodies. To ease the process of creating the API, the AutoScholar publishes sample code. The database admin staff can simply customize the database query strings and either utilize an AutoScholar user role service or implement their own existing service. The API is then ready for use. Note further that by having the API on an institution server, the institution is completely in control of the data flow with the AutoScholar. The code can be inspected and modified to suit the institution's protocols, and it can be installed or suspended on the whim of the institution. Releasing an API is a defining moment in modernizing the data management of an institution and should be celebrated by the whole institution. At a high level, let's look at some sample API code. We first consult the API specification document. Let's say, for example, we want to create the Get Student Course Results call. We can see that the data request must arrive with an action parameter and possibly student numbers. There may also be year and course code specifications which further filter the data call. The results must be returned with the student number, course code, year and semester, the credits of the course, the result code, and, of course, the result itself. Let's look at sample code written in Node.js. We see that the call must also be received together with a session ID, a log token and a user ID. We send these details to the institution's authentication service. Note that the institution may easily customize this part of the code to use their own security protocols. For example, if an institution requires two-factor authentication, then it may add a second layer of challenges to the user. Next, the API checks the request that has been placed. It determines whether the user placing this request has the right to the data being requested. User role management is an important aspect of API creation, and most institutions already have such methods available. The AutoScholar can also provide user roles management as part of the AutoScholar service. So once the API has determined that the request has arrived with a valid access key and that the user has the right to access the data being requested, it then prepares a query to the database, and relays the results back to answer the call. The API can therefore be implemented by customizing the SQL string according to the data structure of the institution, and by calling on the institution's authentication service. It should be clear from this video that the AutoScholar's implementation respects POPI and security and standard principles. The creation of the API is a relatively simple process which, in addition to granting access to AutoScholar, carries several side benefits. We trust and hope your API will soon be implemented.